we go to problem number 4. Notice that we're going quite slowly. We have plenty of time today. I have a wire which has a certain length, L, which is 0.15 meters, and I have a current in that wire. Now that's a little bit funny, because you can't have a current in a wire with a certain length, because then you get pileup of charge. So let's assume that the wire continues here and continues there, but we're only considering this portion. We have an XYZ coordinate system. Let this be Y, this Z, and this X. Convince yourself that it is a right-handed coordinate system. There is a B field in space, and you're being given what Bx is, what By is, and you're being given what Bz is. And you're being asked what is the force on the wire. Now, the force on a very small element dl of the wire, that force would be dF, which equals I times dl cross B. That's an immediate consequence of the V cross B force that we just discussed. But since here dl and B always make the same angle with each other, the wire is not snaking through space, and B is uniform, there is a sine theta, which is a constant. It's not 1, it's not minus 1, but it is a constant. So therefore, if I do the integration, I can say that the force on that whole wire L equals I times L cross B. So I can take the wire as a whole. I don't have to worry about that the angle here is different from the angle here between DL and between B. So that's why this simple result holds. L itself equals Lx times the unit vector in the I direction plus Ly unit vector in the Y direction plus Lz unit vector in the Z direction. This is 0. This is 0 because we only have L in the Y direction. And so now we have to do the cross product. The cross product F becomes I, J, K, 0, 0.15 times I, 0, Bx, By, and Bz. And this, I'm sure you will be able to work that out for yourself, is 0.15. This was the length, I think, of the wire, times B of Z in the x direction minus B of x in the z direction. So this is the x component, and this is the z component, and there is no y component of the force. And if you want to know the total force, well, sure, you can do that one. I'll leave you with that.